Hello students, welcome back to RD Chemistry. In this video, I will discuss a concept of energy of the electron. So let's start now. So we'll be discussing energy of the electron for hydrogen-like species or hydrogen-like system which contains only one electron. Okay. So the different types of formula, I will write the formula. Energy of the electron in any shell orbit is equal to minus 13.6 z square divided by n square. This is in terms of electron volt per atom. Energy of electron is equal to minus 2.18 into 10 power minus 18 z square divided by n square in terms of joule per atom. Okay. Energy of the electron is also equal to minus 1312 z square divided by n square in terms of kilojoule per mole it is, where Z stands for atomic number of the species and N stands for shell number or the orbit number. Okay, fine. You know that energy required to remove the electron is known as the ionization energy. How to calculate ionization energy of any species? So I'm going to write ionization energy is equal to ionization energy of the hydrogen atom. Okay, so this is the ionization energy of hydrogen like species, hydrogen like system. Okay, generally into z square divided by n square. The unit depends on the ionization energy. Okay, so ionization energy of the hydrogen atom is equal to minus of energy of the electron in the first orbit. Okay, previously seen the values. So this can be 13.6 in terms of electron volt, 2.18 into 10 power minus 18 in terms of joule per atom. Okay, or it can be 1312 kilojoule per mole. Fine. These are numbers from the previous set of formula list. So we'll have to remember. Remember z square divided by n square in both the sets of formula. Okay, previous one and this one. Right? Okay, we'll solve some problems. Read the question. What is the orbit number n value is supposed to calculate? If the electron is having energy minus 3.4 electron volt, also calculate angular momentum of the electron. First we'll calculate orbit number. You know that we have the formula. Energy electron any orbit is equal to, say they are given in terms of electron volt. So let me make it a minus 13.6 into z square divided by n square. Okay, in terms of electron volt per atom. Right? Now Z for hydrogen atom is equal to 1. Electron can be anywhere. Okay, it can be in the first shell, second shell, third shell, based on the absorption of the energies. It may be in the excited state. We have to find out what is that orbit number for minus 3.4. So what I'll do now, energy of the electron is equal to minus 13.6 into 1 square is 1 and n square we'll have to calculate. So energy of the electron is given minus 3.4 electron volt is equal to minus 13.6 electron volt divided by n square, and this n square is equal to 4 it comes. Therefore n orbit number shell number is equal to 2. Correct? Now We have to calculate angular momentum of the electron. How to calculate? According to Bohr's atomic theory, we have the angular momentum of the electron. Angular momentum of the electron, MVR, is equal to NH divided by 2 pi. This is one of the postulate. So we have calculated N is equal to 2 into H is the Planck's constant 6.626 into 10 power minus 34, and its unit is a joules a second, divided by 2 into 3.14. Okay, so these two get cancelled. Final unit is a joule second. So this is approximately 2 into 10 to the power minus 34 in terms of joules a second. Fine. So this is clear. See the next question. A single electron system at ionization energy 11180 kilojoules per mole. Find out the number of protons in the nuclear system. Number of protons is equal to atomic number Z. You'll have to find out. Okay, in the atom you have to calculate, not per mole. So they are used ionized energy. I'll write down the formula. Ionized energy of the any species is equal to ionization energy of the hydrogen-like species into Z square divided by N square. Okay. They are given ionization energy 11180 into 10 power 3 joules per mole. I don't want this energy per mole. Per mole means there are Avogadro number of particles. So what I'll do now, I want to calculate per atom. So divided by Avogadro number 6.023 into 10 power 23. I'll get this joules per atom. So what I'll do now, this ionization energy given 11180 into 10 power 3 divided by, this is a per mole, but I want per atom. Then you have to calculate number of proton present in the atom per atom, single atom. So 6.023 into 10 power 23 is equal to, now we'll have to calculate for per atom, right? So ionization energy, previously I said there are different quantities, electron volt per atom, joule per atom. So now we want joule per atom. So it is a 2.18 into 10 power minus 80 into Z square, you have to calculate, divided by single electron, one electron is there in which shell. What do you mean by ionization energy? Ionization energy is the energy required to remove the electron from the first shell, if there is only one electron, to bring it to the infinite distance. So take n is equal to 1. Okay, fine. Therefore, when you simplify this one, Z square will get approximately equal to 9. Therefore, Z is equal to 3 I am going to get. So there are 3 protons in the nucleus. If there are 3 protons in the nucleus, can we guess the atom? Hydrogen, helium, lithium. Okay, right? Lithium atomic number is Z is equal to 3. So it is a 1s2, 2s1. The atom. Hydrogen like species means should be only 1s1. Okay, this is a hydrogen like species. That means 2 electrons have been removed. So lithium plus 2 state. Right? Hope this is clear to you. If you are watching for the first time, please do subscribe, like and share the videos. Thank you for watching. Have a nice day.